Good afternoon, everyone. This is our MAVEN Atlas V pre-launch news conference. MAVEN scheduled for launch at 1:28 p.m. on Monday. And here to discuss the upcoming mission, the launch vehicle and the spacecraft, is Jeffrey Yoder, the NASA Deputy Associate Administrator of Programs from the Science Mission Directorate at NASA headquarters in Washington. Omar Baez, the NASA Launch Director from the Launch Services Program at the Kennedy Space Center. Vernon Thorp, Program Manager for NASA Missions from United Launch Alliance. David Mitchell, the NASA MAVEN Project Manager from the Goddard Space Flight Center. Guy Beutelschies, the Lockheed Martin MAVEN Project Manager from Lockheed Martin Space Systems Company in Littleton, Colorado. And Clay Flynn, the Launch Weather Officer from the 45th Weather Squadron at Cape Canaveral Air Force Station in Florida. And we'll begin first with our opening remarks from Jeff Yoder. Jeff?
Thanks, George. Of course, MAVEN is a list of ongoing and future missions that will continue to improve our understanding of Mars and help inform us in planning for future human missions to Mars. Of course, human mission to Mars is our ultimate destination in the solar system for humanity as well as a priority for NASA. Now, MAVEN is going to focus on the study of the upper atmosphere of Mars to determine the processes at work that are capable of removing the atmosphere. And we'll hear more about this during the science portions of our discussions. But MAVEN also is a great example of NASA's commitment to strong public-private partnerships that will keep our nation in the forefront of Mars exploration. MAVEN's team includes government, industry, and universities, and I'll read this so I don't leave anybody out. The principal investigator institution is the University of Colorado at Boulder's Laboratory for Atmospheric and Space Physics. The project is managed by NASA's Goddard Space Flight Center. The team also includes the University of California, Berkeley, Lockheed Martin Corp., and the NASA Jet Propulsion Lab. In preparation for launch, the team has handled numerous challenges and have taken them head on and have overcome them to where we are today. Thus far, I'm just completing our flight readiness review. We're on track for our launch, the vehicle and the spacecraft, on track for our launch Monday. George?
All right, thank you, Jeff. Now to Omar Baez, the NASA Launch Director. Omar?
Thank you, George, and good afternoon, everyone. And thank you for attending today's brief on MAVEN. I'm very fortunate to be here representing the men and women from the NASA Launch Services Program at the Kennedy Space Center and our partners, United Launch Alliance. These folks have been dedicated to analyzing, fabricating, assembling, preparing, and testing the Atlas V and the MAVEN spacecraft set for launch 3 days from now. Please roll a short tape I have here on some of that processing, please. The Atlas 4.1 will be used for this mission. The booster arrived from ULA's Decatur, Alabama fabrication facility on the ship, the Foss Mariner, which you see here. And actually some of you in the audience here were able to tour that along with me for the first time. Interesting ship in that it's 312 feet long, 84 foot wide, and drafts about 8 feet. And can hold 3 core sections of the Delta IV. This is the Atlas V booster being rolled out to the pad, or to the ASOC facility for its initial receive inspection. Erection of that booster started on October 11th. Right smack in the middle of a government shutdown, making this flow a little interesting for us here. The fortunate part is our partners, ULA, were able to continue their work through that and able to maintain the schedule. And here we are targeting November 18th, which is what we initially started with. So we made up some time there. The Atlas V uses RP1 as its main fuel and LOX, and the Centaur, which is right under that stack there, which is the integrated, encapsulated MAVEN spacecraft, uses hydrogen and oxygen for its fuel. That particular event of the encapsulated spacecraft going up on the Atlas happened last week. The folks completed the spacecraft aliveness tests and the integrated systems tests, which test the flight program and the flight sequences from the start of the countdown through spacecraft SEP. This Wednesday, we just completed our flight readiness review. Yesterday, we held our mission dress rehearsal, and this morning we completed our NASA launch readiness review. All were very successful. Tomorrow, we plan to roll the vehicle out of the vertical integration facility. Should be out of there at 10 in the morning. We'll then connect the electrical fluids, pneumatics, and the environmental control system. Sunday will be a day of rest for most of the crew. And then Monday at approximately 6:30 in the morning, the team will power up the Atlas and the Centaur and perform the flight control checks and facility chill down. Our launch management team will be in place at around 9 a.m. for call to stations. At 10:48, we have our first hold at T-minus 2 hours. This is a 30-minute built-in hold. At the conclusion of that hold, I'll poll the team for concurrence to proceed into lighting the cryogenic commodities on board. And that should start about 11:20 in the morning. Approximately 2 hours later, we will enter our 10-minute hold at T-minus 4 minutes. And at 1:15, I will poll the team for concurrence to enter terminal count and release the hold at 4 minutes. After confirmation that the spacecraft is configured for launch at approximately 4.5 minutes from launch, I will inform the ULA launch director that NASA's go for launch for an expected T0 at 1:28 p.m. on Monday. Our window is good for 2 hours starting at 1:28, so we are good till 3:28 in the afternoon. Thank you very much. Back to you, George.
All right, thank you, Omar. And now to Vernon Thorp, the program manager for NASA missions from United Launch Alliance. Vern?
Okay, thank you, George, and good afternoon, everyone. We are privileged and very happy to be here today, just 3 days from the launch of the MAVEN satellite. Our ULA team started working with NASA and Lockheed Martin to integrate MAVEN onto Atlas almost 3 years ago. Early 2011 is when we started the integration process. We began building the vehicle in Decatur, Alabama around 2 years ago. And during that time and continuing through the processing of the satellite and the launch vehicle here at the Cape, our ULA team has worked very closely with NASA and our other mission partners to get us to this day, and on Monday to a successful launch. It's been a tremendous team effort so far. ULA is proud to provide NASA's ride to Mars for this great science mission. Over the last decade, ULA vehicles have successfully launched all of NASA's missions to the Red Planet, including the Spirit and Opportunity rovers, and then most recently, just a couple of years ago, the Mars Science Lab with the Curiosity rover. In fact, I counted it up the other day, MAVEN will be our 7th Mars mission since 2001. And actually, our first launches to Mars occurred 49 years ago with the Mariner 3 and Mariner 4 spacecraft in 1964. We used the Atlas Agena at the time, that some of you might remember. That upper stage was a little smaller than the Centaur we use today. So as I mentioned, one of those 1964 launches was Mariner 4. It was the Earth's first successful mission to Mars. It was a flyby mission, and if I recall correctly, it returned 21 images as it flew by. And I think it's an amazing testament to how far spacecraft and instrument design has come when you compare that data to the amount of data that the MAVEN spacecraft is going to return. MAVEN will be ULA's 10th launch of the year. This will also be our 41st Atlas V mission, and it'll be the 76th mission we've flown since ULA was formed almost 7 years ago. Several years ago, Atlas V received NASA's highest and most rigorous level of certification, what we call Category 3 certification. That allows the Atlas V family of vehicles to fly NASA's most complex and valuable exploration missions. And the specific Atlas V configuration that we'll use for this mission is the Atlas V 401. That's the vehicle that has a 4-meter payload fairing. The booster is powered by an RD Amros RD-180 engine. The upper stage has an RL-10A4 engine, and this mission will not require the use of any solid rocket boosters. Omar showed you some of the activities that got us to this point. I would now like to roll a video and show you what we hope to see on Monday. So there's our vertical integration facility. Tomorrow morning, the mobile launch platform with the vehicle on top will roll out to the pad. Here's a 401 on the pad from a previous launch. We'll lift off. This lift-off will be one of our slower lift-offs because we have a fairly low thrust-to-weight ratio on this vehicle without the solids. Since we don't have any SRBs, the first major event you're going to see is when we deplete all the propellants in the booster stage. That will happen a little bit more than 4 minutes into flight. At that time, we'll shut down the engines and we'll separate that booster stage from the Centaur upper stage. We'll begin conditioning the Centaur engines for the first of 2 engine burns. And around 10 seconds after that separation event you see there, we will light the engine. We're chilling down the engine right now, just flowing raw propellants through it. We'll light the engine when all the thermodynamic conditions are correct. And that first engine burn will last about 9.5 minutes. 8 seconds into that burn, we'll jettison the payload fairing like you just saw. So after 9.5 minutes, we'll shut down, we'll enter a coast phase. That coast will last about 25 minutes. And then we'll be in the position for the second engine burn. So we'll light the Centaur engine again. That second engine burn will last about 5.5 minutes. And at the end of that burn, we are on our way to Mars. Spacecraft separation will occur about 6 minutes after the completion of that, after we've oriented the vehicle to the right separation attitude. Total duration, if we launch the beginning of the window tomorrow, will be about an hour. And after we separate the spacecraft, we'll do the usual collision and contamination avoidance maneuvers with the Centaur upper stage to make sure that there's no chance of coming into contact with the spacecraft or with Mars, for that matter. We want to make sure we don't become a source of contamination. So I mentioned that we'll separate the spacecraft about an hour into flight. That time could vary by as much as 18 minutes. It depends on exactly when in the window we launch. We've got a 2-hour launch window. We have opportunities to launch the first and last second and on every 5-minute increment in between. And depending on exactly which of those opportunities we choose, the timing could vary by up to about 18 minutes. So if we launch a little later into the window and the mission takes a little longer than an hour, that's not a problem. There's no cause for alarm. Let's see, spacecraft separation will happen near Australia. It'll take about 10 months once we're done with our launch vehicle phase of flight then for the spacecraft to get to Mars. The data MAVEN provides will help planetary scientists understand the history of climate change on the red planet and advance our understanding of both the Martian and our own Earth environment. And ULA is honored to be a part of science missions like this. In fact, we're proud to serve a critical role in delivering payloads to orbit for all of our government and commercial customers. You know that we do it one launch at a time, and we're focused on perfect product delivery for this and every one of our launches. So once again, I'd like to say thanks to all of our partners out there who have helped us get to this point. And with that, I'll turn it back to you, George.
All right, thanks, Vern. Now to Dave Mitchell, the NASA MAVEN project manager from the Goddard Space Flight Center. Dave?
Thank you, George. Well, we're after all these years, we're just a few days away from going to Mars. It's a very exciting time for us here on the threshold there, and I can't tell you how incredible this feels. And when I say all these years, I'm talking about from its inception with the principal investigator and a couple of the scientists with him. They started this in 2003. So it's been a long journey, and just now, just days away. It's very exciting. I'll pick up on the timeline from Vern, but before I do, I just wanted to go back and acknowledge the various institutions that have been involved: the University of Colorado, the Goddard Space Flight Center, Lockheed Martin, Berkeley out at the University of California, and the Jet Propulsion Lab. From the spacecraft side, not even talking about the ULA and the NASA KSC LSP and the U.S. Air Force. But these 5 institutions that comprise the spacecraft partnership have been incredible. I mean, we're at this point, we're poised to launch on day 1 of what we submitted as our final proposal 5 years ago. We put in there November 18th, we wanted to be launch ready at the opening of this 2013 period to get to Mars. And we're on threshold of getting there on that day. Weather and other things can set you back, but to be there launch ready, it gives us time to deal with anything downstream. So kudos to the team. It's not only on time, it's on budget. It has the full capability that we proposed years ago, and it's been fully checked out. So just a great job by the team. So I wanted to mention that. So picking up from the timeline from what Vern was talking about. So we'll separate from the Atlas launch vehicle roughly about 52 minutes after launch over Western Australia. There's a couple of ground stations there that will pick up the transmissions from the spacecraft, give us the health status that all is well. We will deploy the solar arrays and be completed with the deployment sequence about 15 minutes after separation from the launch vehicle. It'll spread its wings. It's 37.5 feet tip to tip on the solar array, so it'll be in its configuration as it needs to be as it flies to Mars and carries out its mission. From there, we'll do a series of checkouts of our spacecraft systems, and on December 3rd, we'll do the first of 4 trajectory correction maneuvers. That one will occur on December 3rd. And the final one will occur in September of 2014, pointing us in the precise location we want to be as we get to Mars orbit insertion. From there, we will start checking out all our instruments. So there's a total of 8 instruments on board and a electro-telecom relay package on board. And so in the first 2 weeks of December, we'll have turned on all the instruments and checked them out. They won't be in the condition or the configuration for taking science. We have to get to Mars first and get into that orbit before we do all our deployments, but we'll at least be able to turn on all the instruments and make sure that things are operating as we intended. From there, we continue on our chase to get to the red planet, and we will, as we're proceeding in this 10-month-long journey to the red planet. And to put it in context, it took 3 days for the Apollo astronauts to get to the moon. So it's quite a big difference taking to get to Mars. But we'll continue on the track getting there. And as we're going, we will do additional calibrations and checkouts of all the systems. In February, I mentioned the 8 science instruments turned on in December. In February, we'll turn on the electro-telecom relay package. And that's something that's used for relaying data and commanding between the rovers at Mars and back to Earth. We already have other spacecraft. The Mars program has other spacecraft up there with this capability, so they're doing that now. But MAVEN will come in down the road to manage that part of it as well later than the primary science we're at. So the big event coming in September, if we launch on Monday this coming week, we'll get to what's called Mars orbit insertion on September 22nd of 2014. It's almost like another build-up to a launch, like we're here today, getting ready for this big moment of launch. Now we're going to be getting ready and training and testing and making sure everything's in the right shape, and we get into this Mars orbit insertion. So what happens is we'll do a burn that will get us into what's called a 35-hour capture orbit around Mars. And then over the period of a couple of weeks, we'll walk down the orbit to get to an ultimate 4.5-hour period orbit, which will be in an elliptical orbit. About the furthest most point it'll be at Mars is about 6,000 kilometers, and the closest point will be about 120 or 150 kilometers from the surface of Mars. So every 4.5 hours, it will go through the furthest point and the closest point all the way through a complete cycle. And that's important from an instrument standpoint. And what I'd like to do at this point is roll the first video, please. Okay, this shows the configuration as we'll be flying once we're at Mars. So all the appendages have been deployed. Not all of them will be deployed this coming week after we launch. Again, we have to wait till we get to Mars to do that. But there's, it really is, the spacecraft is bristling with instruments. And there's a graphic here that points to the various instruments. There's some on booms for various reasons. There's some on the body of the spacecraft around the high gain antenna, that silver circular dish you see there. And then down at the bottom of the graphic, you'll see a boom down there that has actually 3 instruments on board that allow us to slew around and observe Mars in different ways depending on which part of the orbit you're in. So the scientists really took a clean sheet approach when they developed the MAVEN mission of what are we going after with the science, and what kind of instrumentation do we need. And so we collectively as a team came up with instrumentation that really goes after ultimately the question that we're on, which is the climate. What's happened in the history of Mars? Why did it go from a wetter Earth-like environment with a thicker atmosphere to where it is today, much more dry and thin atmosphere? So they pulled together a series of instruments that really will go after I'll say a missing piece of the puzzle of the Mars story, which is many missions with rovers, with other orbiters that are up there. They've been more focused on the surface and what's going on the surface of Mars, where this one is devoted to understanding the upper atmosphere at Mars, understanding it over a period of time of a year to understand how it changed, and then be able to project back in time. And what are the drivers behind it? The solar storms that happen and how that influences the upper atmosphere when those kind of things are happening. So then we get into, once we get through Mars orbit insertion in September of 2014, we go into a 5-week commissioning phase, and that includes these deployments that I was mentioning earlier. It includes the walk-down type orbit to get to the 4.5-hour period orbit. And so by late October, early November of 2014, we'll be in the science phase commissioning and done with commissioning and into the phase we need to be to take our 1 year of Earth year science. In this period of 1 year, we'll also do 5 deep dip campaigns, which are 5 days long, where we lower what's called the periapsis, or the closest approach to Mars, to go from roughly 150 kilometers down to 125 kilometers. And that's of interest to the science community, get closer in. And then we'll pop back out to 150, and then again with the apoapsis, or furthest most point, out to 6,000 kilometers. So Guy is going to pick up where, well, he's actually going to go back a little bit and talk about Guy Beutelschies, who will come next. He'll talk about how we got here, how we got to the launch pad, and how the team executed, and he'll show some really neat video. And it's video of hardware and the people that are doing it, and it really is about the team and the people that have gotten us here. I'm sure most know, there's incredible sacrifice on the people working the job and the families to get us to this kind of point, and to be ready on day one. It really is a testament to what the team has gone through. And you know, Guy, from the side of the partnership with Lockheed Martin, he's been really a steady helm, great colleague for me to work with, and I really enjoyed the time working with him and his team. And I've got to say, you know, all the other partner institutions as well across the board. What a group we've had working together, and just to be at this point. But there's a lot of heavy lifting going forward. We've got to get there safely. We've got to get the data that these scientists have been pursuing for the last 10 years. And so we've got a long way to go, but it's great to get to this point, and on budget, on schedule, with full capability. So with that, I'm going to turn it back over to George.
All right, thank you, Dave. And now to Guy Beutelschies, the Lockheed Martin MAVEN project manager from Lockheed Martin Space Systems Company. Guy?
Thank you. This really is the culmination of a lot of hard work by a project that is very passionate about what they're doing. I mean, we're going to Mars, getting to work with Bruce and Dave, and see the science side of that and what they're trying to do. Is something that's very gratifying to us. Is that the whole team has put in literally hundreds of thousands of hours, literally hundreds of reviews. Thousands of hours of testing, and to be at this point, just a couple of days before the opening of our launch window, ready to send our spacecraft to Mars, it's extremely gratifying. What we've done is we put together a video kind of showing some of the testing and operations we've done since we've arrived here at Kennedy Space Center. So let's go ahead and roll the video. So here we are. This is back on August 2nd. So we arrived on an Air Force C-17 transport plane. So what we have is we have our spacecraft safely encased in its shipping container, and we used the C-17 to get down here, which was really a nice ride. It really eliminates a lot of the concerns we have over, putting it on a truck and keeping it on the highway for days at a time. We can get down here in one day. So we arrived here. We took the spacecraft and the shipping container over to our processing building here at KSC. We took it out of the shipping container. You can see that kind of protective enclosure to make sure that it's kept protected and kept clean. And then here we are taking the spacecraft, and we're going to put it on a piece of ground support equipment. And this ground support equipment will allow us to do all of the checkouts and testing that we want to do while we're down here getting ready for launch. So we had the high gain antenna taken off and shipped separately. To make sure that it wasn't going to get damaged and to allow us some more access while we finished out some closeout work. And then we installed that high gain antenna, and you can see the piece of GSE. It's actually a turnover fixture, so we can actually take the spacecraft and not only rotate it to work on different sides of the spacecraft, but to rotate it up and allow access to areas underneath the spacecraft as well. Now, I love this test. This is a solar array test, so we're checking the solar arrays to make sure that all of the circuitry still works. Everybody knows that you shine lights on the solar array and you get electricity out. Not as many people know if you put electricity back in, you can actually make solar cells glow. So it looks like a kind of a giant LED screen. We also did a series of deployment tests while we were down here. So this is the Solar Wind Electron Analyzer instrument, which is on a boom. And so we actually did a deployment test on it. And we don't have a video of our articulated payload platform boom deployment test as well, but we do have one here of the solar arrays. So we put the solar arrays back on. We did a test where we fully unfurled the solar arrays, and we're actually using the same commands we're going to use in flight. So we process the same commands, just like the spacecraft thinks it's out right after separation, unfurling those solar arrays. And then we actually shine bright lights, we actually call them Hollywood lights, onto the solar arrays and actually check each string to make sure that we're getting the expected amount of power out of that. So here we are, basically closing up the solar arrays for the last time. The next time it'll deploy will be right after separation. And then we did a test where we put it on a fixture that basically rotates the spacecraft around. And the reason that we want to do that is that fixture is very sensitive and will actually give us information about where the center of mass of the vehicle is. Very important to pass along to the launch vehicle folks. They came over and we worked with them to put the spacecraft inside the fairing. So there you can see all buttoned up, and then we put it over on a truck, and then drove the truck over to the launch pad. And you saw earlier the video of the entire assembly being put on a crane and hoisted to the top of the Atlas launch vehicle. We do this in the middle of the night so that keep traffic low and keep everybody out of our way. So very successful operation. And the spacecraft is now safely sitting on top of the rocket. And yesterday, we actually turned on the spacecraft for the very last time. It will now remain on through launch, through cruise, through science operations, hopefully several extended missions, and get all that science data that the science team is desperately waiting for. We are currently supplying power through ground support equipment. So the batteries are online, but we're putting extra power in there so we keep the batteries fully charged. at when we go through our terminal countdown at T minus 4 minutes, there's a built-in hold, and at that point we're going to transition to internal power. So we'll basically take power away, will no longer be supplied by the ground. The spacecraft will be operating on batteries, and it'll stay operating on batteries through the boost phase, through separation, and then that will power the deployment of the solar rays, and then the spacecraft will orient itself to get the solar rays pointed at the sun. So, and at that point, our job down here at KSC is done, because we have a mission support area back in Denver, Colorado, that's going to be taking over control of the spacecraft. So they'll be looking for the data coming from the Deep Space Network, and they'll start taking a look at that data coming back from the spacecraft to determine the health, make sure everything survived the launch, and start preparing for all the activities we're going to do to crews leading up to Mars orbit insertion next September. Also, we do have a Science Operations Center at the Laboratory for Atmospheric and Space Physics up at the University of Colorado in Boulder. And that's the place where the team is going to be looking at all of the data coming from the instruments and routing it to the instrument home institutions, and then also during science phase processing all the science data, and then coordinating all of the activities that the science team want to do. So they'll be basically assembling the sets of commands that they want to send to the science instruments, and then shipping them down to our MSA down in Littleton, down in Denver, Colorado. And this MSA in Denver is already operating several spacecraft. We have a long history with that MSA, a lot of very experienced people. In fact, Mars Reconnaissance Orbiter and Mars Odyssey are being operated right now. So, and they're very excited to get a third Mars orbiter to be operating from the MSA down there. And that's kind of a theme of the entire MAVEN project, is a tremendous amount of heritage. So the MAVEN spacecraft design is built heavily on the MRO, Mars Reconnaissance Orbiter design, with some upgrades that we did for the Juno spacecraft that NASA has launched and is on its way to Jupiter. The science instruments themselves have a tremendous amount of heritage. All of them built or based on designs successfully flown on other NASA missions. Goddard, it's been great to work for them because they have such a rich heritage of successful science missions. And so between all of these organizations, all of these, the designs of the hardware, it's not just that, it's the people. The people really have a ton of background in science spacecraft and a ton of background, frankly, in Mars spacecraft. A lot of people, this isn't their first Mars spacecraft. And so we're really building on not only the designs, but the experience, processes, procedures that the people bring to this process. And so we're very excited. So we're a couple days away. The team is ready. The spacecraft is ready. And we're looking forward to the opening of our launch period on Monday. Back to you, George.
Thank you, Guy. Now we'll look at Monday's weather with Clay Flynn, the launch weather officer from the 45th Weather Squadron, the Department of the Air Force, from Cape Canaveral Air Force Station. Clay?
Thank you, George. The cold front, you may recall a cold front pushed through earlier in the week and transited central Florida and actually south of the peninsula. That front's actually migrating back up to the north now, associated with an upper level disturbance in the eastern Gulf of Mexico, giving us quite cloudy conditions. If I could have the satellite picture, if you look out in the eastern Gulf, you can see that disturbance. We're quite cloudy. That disturbance will lift north, give us isolated showers this afternoon and evening into tomorrow for tomorrow's MLP roll. So would look to have some isolated showers in the vicinity for the roll. That's really not a constraint for rolling to the pad. We've got a low lightning threat, and winds don't look to be an issue. We should have southeast winds gusting in the mid to upper teens at a couple hundred feet, so no real significant issue for a roll tomorrow. We should see a gradual decrease in the shower threat tomorrow afternoon and into Sunday. Moving on into launch day. On launch day, there should be a cold front. The next cold front should be in northern Florida. I believe it'll be just to the north of us during the afternoon hours, with the bulk of the shower activity staying to the north. However, in advance of the front, do expect to see some showers develop Monday morning. We're quite moist, a little more moist than typical for November around here. So we're pretty saturated next week. So do expect to see showers in the morning. That would be and into increasing through the afternoon hours. Relatively low lightning threat during the count and during the window. However, with the showers and southerly flow and influx of moisture, would be concerned with thick clouds because we do have quite a bit of moisture in the atmosphere, cumulus clouds, and disturbed weather associated with isolated showers. So in general, those will be the three weather rules that we're concerned about on Monday. In the event we don't go on Monday and we push on into Tuesday, that frontal boundary that should just be to the north of us, Monday afternoon should push through during the overnight hours. Monday night, Tuesday morning should be just to our south. With the front pushing to the south, the pressure gradient tightens up quite a bit. The tighter the pressure gradient, the stronger the wind. So look to have some gusty winds on Tuesday from the north-northeast. Would look to have fairly significant gusts in the upper 20s to low 30s Tuesday afternoon. And whenever we get on strong onshore flow, even though we're post-frontal, the front doesn't move that far to the south. With the strong onshore flow, looking for a coastal shower threat, and then once again that would give us disturbed weather associated with showers and cumulus clouds coming in off the water, as well as we're still fairly moist behind that front, so a thick cloud rule concern as well. In the event of a 48-hour delay, the front looks like it continues to push a little bit further to the south. However, the pressure gradient still remains or looks to remain fairly tight through the middle of the week, next week's, and really would look to see for winds gusting in the mid-30s. The wind constraints or the wind gusts I'm giving you are really at a couple hundred feet, not necessarily at the surface, but at a couple hundred feet gusting in the low to mid-30s on Wednesday, which would be a concern. And again, anytime we have those strong winds from the northeast coming off the water, would look for isolated showers and disturbed weather and potentially a thick cloud, although I don't think we're that moist in the mid-levels by that time. And that's all I have, George, unless you have any questions.
All right, Clay, thank you, and we're ready to take questions. Please give your name and affiliation when the microphone comes to you, and we'll start here in the back.
Jason Ryan for Spaceflight Insider, and I guess this question's for Dave. On MRO, the main instrument is HiRISE, I believe, that a lot of people are familiar with. If you had to pick one out for MAVEN, which would it be?
Boy, that's tough. It's like, which kid do you like the most? So, you know, they're all, you know, there's 8 of them. They're all special. They all have different things they're going after with the science. That's why, as I mentioned earlier, the clean sheet of what are we going after? What is the science team going after to get to some of the questions about why the Mars changed so dramatically. And so some are interested in, maybe I'm repeating myself a little bit, but some are interested in the ultraviolet from a perspective of 6,000 kilometers. Others, like the mass spectrometer, are interested as we are really close into the surface of Mars. And then others are looking at the solar interactions. There's a whole complement of Berkeley instruments that are very much tuned in with what's happening with the solar storms and how that impacts the atmosphere. So they're all necessary, needed, and we want them all fully functioning. And again, we've checked them out, and we've got a very well-tested group of instruments, but they're all special to me.
Bill?
Yeah, hi, Bill Harwood, CBS News, with a couple. For Clay, you got any odds on next week, for those of us who like odds?
Yes, sir. This morning, the forecast I put out was 40% for Monday afternoon. I think Monday is the most favorable day we have of the 3 days currently scheduled. Tuesday looks less favorable. It's about 60%, and winds become a concern as well on Tuesday. And on Wednesday, I think it's a little bit worse, principally because of the stronger pressure gradient, the tighter pressure gradient, the stronger wind. So I went 70% for Wednesday afternoon, sir.
Thanks. And for David or Guy, this may be in the press kit somewhere, but I know there's a science briefing Sunday. But for the story I'm writing now, when it does a deep dip, I'm just curious if you can characterize either the heating on the spacecraft, whatever marginal amount of extra heating there is, or dynamic pressure that the spacecraft. I mean, I guess if I was standing on the spacecraft and held my hand out, would I feel it? Would I feel the breeze?
A deep dip is kind of when some people hear it, they get a little nervous. And really, again, we're basing our spacecraft design on Mars Reconnaissance Orbiter. And if you remember, Mars Reconnaissance Orbiter actually did a process called aerobraking, where they dipped down in the atmosphere to slow it down every periapsis and pull their orbit into the final science orbit that they wanted to go. And they actually went much deeper than MAVEN is going to go through. So in reference to the kind of the question, what would you feel? I mean, if you put your hand out while you're going through, you'd feel a light breeze. It's not something where, like the Apollo's coming back where you're seeing flames coming off there. It's really, really a modest amount of pressure out there, but it is a tremendous value to the scientists being able to go down and get that in situ measurement of the atmosphere.
Thanks. And one more for David, I think. How does relay play into the mission? Like if you get extended, at some point science stops, relay continues. Does relay happen while you're doing science? How does that play out, the relay function?
So as I mentioned earlier, the Mars Reconnaissance Orbiter and Mars Odyssey have that capability already. Both those spacecraft are flying fine, and excuse me, and we're very hopeful that it continues the way it is. The health of those are showing that the relay will continue for some time. So we're really a backup. We're not going to Mars and immediately implementing that service. We'll certainly check it out and make sure it's ready to support when called upon. But we're after that first year of prime science with the 8 scientific instruments. And then relay is for MAVEN is just a backup at this point. And we wish, as all the assets there, continued good health. So we hope they keep chugging along for a long time. And we're just focused more on the science until called upon downstream.
James Dean, right here in the middle.
Thank you. James Dean, Florida Today. A couple for Omar. First, when do you load the RP-1?
The RP-1 was loaded about 2.5 weeks ago during our wet dress rehearsal, and it remained on board.
Gotcha. Okay, thanks. And I know you and LSP are no stranger to these types of missions, but just wondered if you could speak to again, sort of the excitement of a Mars launch in particular, and would it be correct to say that this is the last Mars mission from Florida that we'll see for some years, as far as you know now?
Yeah, the excitement is unbelievable. Just if you look around this room, the way the media has filled it, that's a testament to the level that of folks that are coming out and are interested in the mission. If you look outside of the community, there's quite an interest in this mission, and you wouldn't think so in that it's not as sexy as the rovers, going over the planet. But this is kind of like a weather satellite for Mars, and it's providing relay, and it's real science. It's an interesting mission, and it's captured the imagination of a bunch. I've got a 9-year-old that asked me questions about it, and they're questions that I have to think about and look at, the literature, because it's kind of, sets me back. So super interesting. I think there's a lot of interest from all realms. As far as on the books, I don't have anything right now from the East Coast or West Coast, but I know that people like the guy next to me here are planning and are looking for fundings to generate missions in the next couple of 5 years.
I don't know if you can confirm or clarify further, but was 2020 likely the next NASA anticipates from Florida to launch to Mars?
Well, so let me talk to the next planned Mars mission, and so this is still in the early phases. But our InSight mission, which is targeted for 2016, and then the Mars 2020 rover mission. So those are the next two Mars missions that are targeted. Of course, they're still going through the planning phases, but. Yeah.
All right, let's come up here to Dan Bellow.
Dan Billow from WESH-TV for Dave Mitchell. Could you elaborate a little bit more on that, I guess, sort of golden moment? When is that when you acquire the spacecraft and you kind of get an understanding of its health? Right. At what point does that come? And talk maybe a little bit about the anxiety level before you get there.
Sure. Okay. So shortly after separation, within a minute, our communications are what's called a TWITA, the amplifier /radio is powered up full. And then within seconds, we have connectivity with the ground stations at Perth and Canberra in Australia. So we'll start flowing data and getting health, at that point forward. So I'm sorry, I missed the second part.
Your anxiety
Oh,
until that's right
okay.
at separation.
Right. So, I mean, we're working hard at this point, and there's a buildup when you're getting to launch, and certainly being in the control room a number of times in the past, there's a level of anxiety, but you're focused on what's next, and focused on the countdown and making sure you're hitting all your marks. And then after launch, it's in the launch vehicle's hands for a while, but then you're focused on what's coming after separation and any kind of contingencies or anything. But there's a lot going on to, I'll say, distract the nerves a little bit. And so it's a big day for us. We're really excited. But I guess what calms me is the rigor of testing that's gone into this program. And so it really, at a system level, really checked out well. So that's what, for me, gives me some comfort that we've got a system that should fly well here, and we're ready to roll here.
Okay, Marcia Dunn.
Hi, Marcia Dunn, Associated Press, with a couple of questions. The 5-minute launch increments, could you explain that a little more? Is that just the first second of every 5 minutes into the window, or how does that work?
Yeah, go ahead. Okay. Yeah, it's basically to simplify the launch process and the targeting process. We made a decision long ago, in cooperation with the spacecraft and with NASA, that we would just target every 5 minutes in the window. That keeps the number of trajectories we have to run, the amount of analysis that we have to do, and the amount of flight computer programming that we have to do down to a reasonable amount. So, we're looking at how much effort we want to put into the trajectory design and the flight programming, and balancing that against wanting to maximize our opportunity. And that's the solution that we came up with, is we'll target every 5 minutes. That gives us a reasonable number of opportunities over a 2-hour period each day. There's a lot of ways we could have done it. That was the optimal approach that we all agreed on.
For Mr. Mitchell, the last week's Indian spacecraft hoping to get to Mars. I've seen different arrival dates for that one. Does MAVEN get there first, or does the Indian one, or does that vary at this point? Assuming you go on time,
right,
or more or less.
Assuming we go on time, and their burns continue the way they hope for. I think they have 1 or 2 more burns in Earth orbit. Getting greater and greater orbits before it takes its final burn and starts heading out. I think that's on November 30th. If we launch on November 18th, we're going to be cruising past them, so to speak, and we'll actually get there, I believe, 2 days before they get there. So it's kind of a neat race, and we wish them all the best. And I think down the road, the scientists will be collaborating on what they find there, between the 2 missions.
I know they're going after methane, but for the rest of their mission, is there much overlap between the 2?
I don't know a lot about the mission other than it's a technology demonstrator, national pride. For India, it has some instruments. I think there's 5 instruments on it. Some that are focused more on the surface, where ours is, again, devoted to the upper atmosphere. As you said, they do have a methane detection or instrument on board, but there's not a lot of overlap, in my opinion, but we will share the science for sure.
Okay, right here.
Rick Lansby with WFIT. After the 1-year science mission of orbiting Mars, are there any plans for MAVEN? What happens next?
Sure, I'll take it. So with any of our missions, our science missions, after their prime mission, we go through a review process to review the science, and we have an independent team look. Do they recommend going into what we call extended phase? So MAVEN would certainly go into a review process to see, from a science standpoint, should we go into the second year of science or the third. Aside from the science aspects, we would still rely on MAVEN as the backup communication system that David had talked about.
Okay, let's come up here to the front to Ken Kramer, right here on the front row.
Hi, Ken Kramer for Rocket STEM and Universe today. I have a couple questions for Vernon Thorp, please. Jeff Yoder, you mentioned that our ultimate goal is to go to Mars. So, Vernon, I'm wondering if you could tell us a little bit about the human rating of the Atlas V that's coming up for Boeing and for Sierra Nevada, as well as what's the progress on the Delta IV Heavy for the Orion next year?
Okay, I can say a few words about that. Yeah, we are engaged in working very closely with NASA right now on human rating our vehicles. I think most folks know that we've actually flown humans on our vehicles in the past, if you go back far enough into the 60s, both Atlas and Titan. Right now, there are several programs that we're engaged with NASA on outside of the traditional science mission area that we're talking about here today. As you mentioned, those are the commercial crew programs, the exploration flight test program, and we're also doing some work with NASA through our parent companies on the SLS program as well. On the EFT program, the Exploration Flight Test program, we are targeting a launch September of next year, and everything is on track for that right now, working very closely with NASA and Lockheed Martin for that flight test. And for commercial crew, as you pointed out, we are supporting both Boeing and Sierra Nevada. The human rating activity that we're doing is probably focused more on the commercial crew activity right now. I think that's where we see the earliest potential for flying people on board our rockets again. But those, I'll say that the work is moving along very well. There's a lot of effort being put into it, and we're looking forward to getting through that in the next year or so and supporting those missions in the very near future, EFT being the first one.
Can you compare a little bit the Atlas Agena at the start of the program to the Atlas V that you're using now?
It was smaller. Atlas Agena was a little bit before my time. I might have been watching some of those missions on TV back in the early 60s. I can't quite remember. But Agena was one of the first upper stages developed for Atlas, and it was quite a bit smaller. I don't know if you could quite get your arms around it, but if you go on the internet and do a search for, say, the Mariner 3 or Mariner 4 missions, it's easy to find pictures of those launch vehicles. And the Agena upper stage was so small that by today's standards, you almost wonder if that's, is that the payload or is that the upper stage? Needless to say, Centaur is a lot bigger, a lot more powerful. Centaur was specifically developed to be a very high energy, very accurate upper stage. But some of the early missions, even the early interplanetary missions, did not require that level of power. The flyby missions didn't require quite the level of accuracy, so Agena worked fine for those. And I know that I think in the early 70s there was probably a plan to continue that program, continue the Agena upper stage. A lot of people really liked it, but there just really wasn't a need. So all the efforts really went into the Centaur instead. One thing I do remember about Agena, I'm a thermodynamicist, a thermal analyst by training. And so maintaining a proper air-conditioned environment inside the payload fairing, especially on a hot floor today, is very important to us. And the Agena fairing was small enough that you could actually put an insulation blanket around it, and then that blanket would pull away at liftoff, which there are some other vehicles in the world who've done that recently, but when you get to the upper stages and payload fairings the size of the ones we fly today, that's really not practical anymore.
Okay, we're going to stop and take a couple of questions we have on the phone, and then we'll come back here. Miriam Kramer from space.com.
Hi, thank you. Yeah, I am wondering if maybe you could elaborate a little bit. I think this is for Vern or for David, about the historical context sort of this mission. So what did the previous orbiters teach us about Mars, and sort of what what specifically is very different about MAVEN? Thank you.
Sure, I can start, and Guy, he has some spacecraft they're flying out there that I'd like him to elaborate on. But again, there's a heavy emphasis earlier in other missions on what's happening on the surface of Mars. You know, what happened to the water, and you know, understanding topography and so on. So there's a lot of evidence of liquid water flowing, rivers, perhaps lakes, perhaps oceans on Mars and in the ancient Mars environment. So they were really after that, or they are continuing to be after that, and they have different types of instruments, cameras that are focused on the surface, the MRO with a very large camera and high rise that really is has an entirely different mission than ours. So again, ours are fully focused on the upper atmosphere research here. But I'm going to turn it to Guy, who's again, his shop is they're flying a couple other Mars missions there right now.
Right, and the MAVEN is the spacecraft design's based on the Mars Reconnaissance Orbiter, which in turn derived a lot of its heritage from Mars Odyssey. And Odyssey and MRO, of course, are still in orbit around Mars doing their missions. And so there's a lot about the design with MRO that is very common, almost identical. There's some things about going to Mars that don't change mission to mission. The communication system, for instance, the electronics and computers, you know, they become obsolete, and so we've done some upgrades on those that we did for Juno, and we're deriving the benefit. But the propulsion system, and you know, that's another one that is very similar. So when you look at MAVEN and then you look at MRO, the things that really pop out are the things that are mission unique. MRO is in a tight circular orbit, which is good for taking, basically doing mapping of the surface of Mars, but we're an atmospheric monitoring mission. And so what we want to do is we want to come close to the planet, and then we want to get away from the planet so we can see all the interactions with the solar wind and the atmosphere. So that elliptical orbit kind of drives the configuration of the spacecraft. We have a large number of instruments that want to take a look at the solar wind, so they're kind of fixed looking at the sun or at fixed angles off of the sun. And so the body of the spacecraft, unlike MRO, is during its orbit, it stays on the sun. And we have a smaller number of science instruments and smaller than the instruments on MRO that want to look at the atmosphere. So we put those on an articulated platform so that we can just gimbal those instruments. Whereas on MRO, it basically kept the whole spacecraft turning around the planet, and it articulated the solar arrays and the high-gain antenna. We're the opposite. Our antenna and our solar arrays are fixed, and it's only the science instruments that want to take a look at that atmosphere as we're going around the orbit that it's articulated. So there's a lot of heritage going back to those other orbiters, and the differences are really focused on the things that make MAVEN different, which is we're an atmospheric monitoring mission, whereas all the orbiters that come before us have really been surface mapping, surface operation, surface observation type missions.
Okay, another question on the phone from Francie Deep from Popular Science.
Hi, thanks for taking my question. I have two of them. The first one, I wasn't, wondering if you could clarify what we already know about the Martian atmosphere now, and what MAVEN is going to find out. And my second one, I was actually wondering, what will people be able to see of this launch sort of from home, if anybody in the U.S. will be able to see it from naked eye, and how far out they will be able to see it? Thanks.
So the Mars upper atmosphere, the previous missions, there's a puzzle piece, I'll say, that's been missing with what's happening in that upper atmosphere, that the other missions, that was not their focus. So that's really what we're going after in this case. Not sure if that's.
Okay, let's come back here and take a question from Daryl.
Daryl Nailfox 35. I was wondering what the puzzle piece was, and then after that, also to Omar, you mentioned there were challenges during the government shutdown, and you had to overcome some of them as well as some delays. What were the biggest ones, and how did you overcome it, and how did you make up time?
Okay, hitting on the government shutdown, it was pretty disruptive process in that here we are planning for a mission with a very limited launch window of 20 days. And we've done just about everything possible to preserve that time and be able to hit the beginning of that window. We've got all kinds of contingency plans in place, hurricane plans, plans if you have security breaches. You have plans for everything. Nobody could forecast this need to shut down the government that's actually part of the processing of this satellite that's launching 3 days from now. So we had to go through what's called an orderly shutdown and shut down the work that was going because we didn't know when we were coming back. We were very lucky and instrumental, a lot of folks working this to make sure that we were able to get an exemption, although the exemption occurred 2 or 3 days after the shutdown took place, where we had to reverse course. Now we had saved the things that we were doing. Now we had to reverse things and keep on processing. So it was just an unnecessary distraction. We overcame it. But you know, it's something that we couldn't avoid. You know, we can't come to work. He told us not to. It's illegal to do that. So we had to shut down. There was a lot of planning that goes on before one of these things. That was very disruptive, and a lot of people were, instead of being focused on their other jobs, had to focus on this, you know, what does the shutdown mean and what do we have to do to get there? So that's the kind of thing that made it disruptive. Once we were able to get our folks in, it was the right folks that are focused on Mars, then it made the mission quite easy because you didn't have the distraction of any other mission except for MAVEN. You didn't have to feed the normal stuff, training. You just got your job done. And so MAVEN did not get shortchanged. We had the right people, the right focus. But it was a short obstacle that we had to overcome. You got tripped up in the process, and we couldn't predict that. But here we are, and it's 3 days away from launch, and we're going to make it.
Okay, I think we have one last question here, and that's going to wrap it up for us.
Hi, Don Haladiak, CBC. Question for Omar. If the launch is delayed, does the window continue to launch at 1:28? Does it shift? Is it still 2 hours? What is the impact to the window?
For the most part, the window remains about 2 hours, and it does shift a little bit over time.
About 3 or 4 minutes a day.
Yeah, 3 or 4 minutes a day is what it shifts.
Earlier, I think it was earlier.
Yes.
Earlier. All right, that's going to conclude our briefing. If you'd like to get more information, there is a website, which is www.nasa.gov/MAVEN. So our next activity will be a science briefing on Sunday morning at 10 o'clock. And our launch coverage on NASA TV begins at 11 a.m. on Monday, November 18th. So this will conclude our briefing for today. Thank you very much.